Hello and welcome to the next video where we take on challenge number 9 from, or is it 10? I don't know, 9 or 10, whatever it is, from Damn Vulnerable DeFi. And this one is called Puppet V2. And the reason it's called Puppet V2 is because it's utilizing Uniswap V2 liquidity pools. Now, if you haven't watched my explanation from the previous video, I go ahead and recommend that. But I also highly recommend that you do your own research on how this is done. Yeah, let's go ahead and read the challenge. The developers of the last lending pool are saying that they've learned their lesson and released a new version. Now they're using Uniswap V2 exchange as a price oracle, along with the recommended utility libraries. That should be enough. You start with 20 ETH and 10,000 DVT tokens in balance. The lending pool has 1 million DVT tokens in balance. You know what to do. So if you don't know what to do, you need to steal all those million DVT tokens. Now, the difference between Uniswap V1 and Uniswap V2 is now all the tokens are ERC20 compatible, meaning that instead of exchanging specifically ETH for your ERC token 20, what they do is they create a pairing between WETH, which is WETH, and the token. Now, what is WETH or WETH? It's called wrapped ETH, which is essentially a 1-to-1 ratio of ETH to WETH, and you just deposit your ETH into the contract and you get the equivalent wrapped ETH and all the benefits of using ERC20. And then on the contrary, if you want to, unwrap the ETH, you just, click the withdraw button or, a withdraw transaction within the contract and out comes your Ether. So let's take a look at this. So Puppet V2 pool. Let's have a look. So it's doing some funky stuff here. Uniswap pair, Uniswap factory. We have the token WETH. There's an address mapping to track everyone's deposits. The constructor, which sets everything up. Here we go. So here's an important function here called borrow. So this allows borrow amount of tokens by first depositing 3 times this time their value in WETH. Sender must have approved enough WETH in advance. Calculations assume that WETH and borrowed token have the same amount of decimals. So let's have a look at this. So say we want to borrow, 10 DVT tokens. It requires the token balance of this address to be greater than that. It'll calculate the deposit of WETH required. Now, this is going to do pretty much the same thing as the last challenge, but instead of calculating it itself, and this is what I was saying around potentially you could do some numeric underflows or overflows or something like that. In the last challenge, which I didn't talk about, they actually just go ahead and quote it from the Uniswap library, which is a safe way to get that price ratio. So once it gets that price ratio, it then multiplies it by by 3. So if we have this token amount, how much is it going to cost? Then we multiply that by 3. So essentially, if we have a 1-to-1 ratio, then if we want to borrow 10 DVT tokens, it's going to cost us 30 ETH. But in this case, we actually don't have a 1-to-1 ratio. In the initial setup, we can see that the Uniswap initial token reserve is 100 and the WETH reserve is 10. So currently, 1 token is worth 0.1 Ethereum, or WETH essentially, but they're kind of interchangeable. So if we wanted to borrow 10 DVT tokens, it would cost approximately 3 WETH, if that kind of makes sense. Cool. Okay, so let's continue on. So we calculate the deposit required, which came out to be, say, for 10 DVT tokens, it's 3 WETH. They transfer that 3 WETH, and the deposit is then marked, and we transfer that token to the sender. So how do we get the 1 million tokens from this contract? Now, this is pretty much very, very, very similar to how we did it last time by manipulating the market value of the DVT, heavily devaluing DVT in relation to WETH in this case, doing the borrow and then transferring it back. So I'm going to do the kind of same process as before and kind of write out the maths, and then we're going to go ahead and implement it. So you can see this is how they do all the setup here and all this fun stuff. And then it's also good to reference the Uniswap V2 docs, as I mentioned in the last video, but this one I'm not going to go into. I'm just going to assume that you've taken a look at it. Okay, so the first thing that we need to do is do the maths. how this is going to work. So we follow the same process as before with a few extra steps. The pool is initialized with 10 ETH and 100 DVT. And we want to perform a swap to deposit our 10,000 DVT that we have initially to heavily devalue DVT in relation to ETH. So initially we have 10 ETH and 100 DVT. We go ahead and deposit the 10,000 DVT, which then gives us a ratio that looks like this. We have the numerator and denominator, which uses the same values as last time, except this time I'm accounting for the 0.3% fee because it actually does make a difference in this challenge. So the numerator becomes 10,000 times 997. That's your input value. Take away the fee, multiplied by 10 because that's the existing ETH balance. And then the denominator is 100 times 1,000, which is, again, this multiplying here is just the fee coming into action. 100 times 1,000, which is your existing tokens, plus how much you're depositing times the fee. So once we get that, we can then calculate our ETH payout. So from depositing 10,000 DVT, we get a numerator denominator of approximately 9.9 blah, 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 ETH. So we subtract that from the reserve. So it relieves the ratio in the pool to be around 10,100 DVT to approximately 0.099 ETH. Pretty fun. Okay, so the next thing that we need to do is calculate the deposit. So now that we've manipulated the price, let's go and see what the deposit price is going to be to borrow that 1 million DVT. So we have 1 million DVT, which is approximately equal to 9.8 ETH. Now, how did we do that? We calculated, it's from this number here, you can divide by this number here. So, sorry, with this number here, you can divide both sides by 10,100. And once you do that, you'll get the value of 1 DVT. You can then multiply it by 1 million, which will then net you the result of 9.8 ETH. So once we've got that, we then need to make sure that we multiply it by 3, because that's just what is set out by the contract, which leaves us with 29 ETH that we need to deposit. Now, let's check how much ETH we have initially. Where is it? Attacker initial token balance is 10,000. So we initially only have 20 ETH. Now the key thing to remember here is that we got that 10 ETH from depositing our 10,000 DVT initially. So currently we have 20 ETH from the initial, and we have 10 ETH from the swap, which gives us approximately 30 ETH to spend. So just the amount that we need to make the deposit. So the next thing that we need to do is convert our ETH to ETH. Now, why do we need to do that? Because the attacking... So because the contract requires us to use ETH for the deposit, we needed to change our ETH, our existing 20 ETH, to ETH. And to do that, we deposit into the ETH contract, and when we get those get those back. So once we do that, we then are left with this. So we go ahead and hit borrow, and we're left with approximately 0 ETH, approximately 0 ETH, and 1 million DVT. So then after that, assuming a correct value proposition of 10 ETH to 100 DVT, our position has changed from 20 ETH plus 10,000 DVT, which is approximately equal to 20 ETH and 1,000 DVT. So just dividing by 10 to meet this value ratio here. It's approximately equal to 1,020 ETH of value, which is our initial position. Afterwards, we have approximately 0 ETH and approximately 0 ETH. However, we have a million DVT, which is around 100,000 ETH of value, which again gives us approximately a 98% return, sorry, a 98x return, which is a fantastic return here. So let's go ahead and put this into code of how we're going to do this. Again, this is going to be very, very similar to our previous exploit code. So the first thing that we're going to do is get our attack token contracts and connect to them as the attacker. And again, we are going to get that helper function that's going to print out the balances of ETH, and token for the specified address. So we're going to firstly initially log the balances of the attacker, and we can print that out. The next thing that we're going to need to do is approve a DVT token transfer. So we're going to approve the attack router. Now the attack router within Uniswap v2, there's a router rather than you interacting with the contract directly. And the reason being is that it can find different contract addresses. So say you wanted to swap for DVT for, you know, some other token, say DAI, for example, it would swap the DVT for WETH and then WETH for DAI, and then that would come back to you, and you only have to do one contract interaction. So the contract router is basically the one that handles and routes you to all the different destinations. So firstly, we need to approve the router. The next thing that we need to do is swap that 10,000 DVT for WETH. So we go ahead and we want to transfer exactly 10,000 tokens. From our calculations, we want a minimum of 9 WETH in return. The token addresses, so this is what we're passing as like, all right, this is a token that you need to look at. This is the token you need to look at. Can you please translate them? This is the address that we want the value to go to. So we want the ETH to go back to our attacker address, or so the WETH. And then again, the deadline is, if this deadline has already passed, don't process this transaction. Cool. Okay, so after this, we go ahead and we log the we want to log the balances of the attacker and the Uniswap exchange to see where it is at, to make sure it is in line with our calculations. Then the next thing is we need to calculate the deposit required to approve the lending contract for that amount. So now that we've heavily devalued the DVT in relation to WETH, we then want to get a quote to see how much it's going to cost us to borrow that 1 million DVT. So we go to the attacking lender and we ask them, can you please calculate the deposit of WETH required for me to borrow your entire lending, your entire balance? So the required deposit for all the tokens is whatever we get back here, and we want to approve the attacking, the contract, the lending contract, to be able to spend our WETH on behalf of us. So when we request to borrow, it does the transfer for us. Okay, so the next thing that we need to do is transfer the remaining ETH to WETH, and we need to save some for gas. So remember that we only had a little bit of leftover. So we only had around, it was like 29.5 WETH that was required for the deposit. So we have approximately 20 ETH we have exactly 20 ETH in our wallet now. So we want to translate that now to WETH. The way that we do that is by just sending a transaction to the attack WETH address, and we want to call its fallback function, which is basically just sending value to the contract. And the reason that we're not doing a full 20 ETH is because we need to still perform transactions, so we can just do 19.9 and we can save 0.1 for gas. So then after that, we can go ahead and log the balances, and just to see where we are at with the attacker address and verify that we're all good to go. So the next step is to do that, is to verify that we have enough WETH to make the deposit. So we go ahead and verify that our WETH balance is greater than the deposit required that we calculated from up here. The next thing that we need to do is request to borrow the funds. So because we have enough WETH, it's greater than the deposit, we can go ahead and borrow that amount. So we go to the lender, we ask, hey, can you borrow the pool initial token balance? And again, I had some gas limit issues, so I just increased the gas limit here. And then afterwards, that's it. We win, and we can go ahead and log the balances of the attacker and log the balances of the lender. Now, unlike last time, I didn't return the tokens that we had and return the Uniswap liquidity pool back to its original kind of ratio. The reason being is the success condition here is greater than or equal to the pooled initial token balance, so we don't need to get any extra tokens anyway. So that's fine. I'm not sure if that's a bug or a feature or whatever, but all we need to do is make sure that the lending pool has 0 tokens and we have all the tokens. So let's go ahead and run this and see if this works. Yarn run puppet v2. And we can go ahead. Oh, it failed. Assert is not defined. That's a good thing. All right, well, let's go ahead and get rid of that because I thought that would be fine, but apparently not. Maybe it's require. But anyway, we can go ahead and see that we pass it anyway. So if we walk through kind of the different balances as we go through, the initial one is the attacker has 20, 0, and 10,000 DVT. We then swap the 10,000 tokens for WETH, and we can see that the ETH balance of the attacker then jumps to we lose a little bit in gas fees, but we have almost 10 WETH. And no tokens. And we can see the Uniswap exchange has 0.09 WETH in relation to 10,100 DVT tokens. We then calculated the deposit. The deposit required is 29.49 ETH. And if we have a look at our calculations here, we can see we just make that by just 0.5 of an ETH. Then the balance of the attacker, once we deposit the ETH for WETH, we have nearly 30 ETH and a little bit of ETH left. I've said ETH and WETH so many times, I'm sure I'm confusing you all. And then we can see that we swap our WETH for the DVT. So we borrow the DVT here. So we get the 100,000 and we deposit that 29.5 approximately, leaving us with 0.3 ETH. And then the lender, you can see at the end, has 0 tokens, 0 ETH, and 30 WETH. So that's how we go ahead and solve this. I hope you guys learned something, and I'll be back tomorrow. I don't know why I said tomorrow. I'm probably going to do this straight after this, but I'll be back later, and I will be doing Free Rider or Climber or Backdoor. I don't know which one comes next, but stick around and you'll find out. All right, cool. Thanks, guys, and I'll catch you in the next one.